Hey guys, welcome to Real Engineering Mechanics. So here is a question on 3D mechanics. The question is, show that the 900 Newton force in vector form is 791 I plus 403 G minus 146.5 kilonewton. So we have to show this particular force 900 which goes along the line from A to B according to the direction of this particular force. As you can see, it is pointing towards it, so that means it is going from A to B. Then we know our force, if we want to express it in vector form, is equals to the force, don't forget we are dealing with force AB, is equals to the force times the unit vector or dot the unit vector of the position of the force, which is from A to B. And we know our unit vector of this position is the same thing as this. That means in this case we'll be having this particular force from A to B the force AB dot the position of A to B, the position from A to B over the magnitude of this particular position. So, and as you can see, according to this particular point, this point A here, we're already given that it is minus 48. So let's write it out in vector notation. Point A is equals to minus 48 in y direction, minus 25 in j direction, and positive 20 in k direction, as you can see. So from here, let's make O our center. As you can see, from O to A, we go in this negative x direction. So that means they say from this distance to this. That means they said from this distance to this distance is that particular minus 48, and also from here to here is that particular. So as you can see, we are going towards the negative y-axis, and from here to here is towards the positive z-axis. So that's how they go about that. So, and we know if we want to get the position, let's also write our B out first. Our B is 60 in I direction. Also positive 30 in J direction, and positive 40 in K direction. This is how they also go about this. So from here you go from this particular point to this particular point. You are going from O to this particular point here. You are going towards the positive of x. Then from here to here, the positive of y. Then also from here to here, you are heading towards the positives of z. As you can see, you are heading towards the positives of z. That's how they go about it. So if you now want to go from A to B, so that means it will be, we know the distance from A to B is the same thing as B minus A. Are we good? So that means we subtract A from B. So that means we'll be having B is equals to AB to be equals to, open bracket, 60 minus, that's plus 48 in I direction, plus, open bracket, 30 plus 25 in J direction, plus, open bracket, 40 minus 20 in K direction. So if we do this, we have position of AB to be equals to, that's 108 in I direction, then positive 55 in J direction, then positive 20 in K direction. That is the position from A to B. Are we good? So we can now go into this our particular force. We have force F of AB to be equals to, we are given a particular 900 force. So that's 900 into bracket this position 108 in I direction, plus 55 in J direction, plus 20 in k direction plus 20 in k direction over 1 square root magnitude of this, that's square root of this, 108 square plus 55 square plus 20 square. So that means we'll be having 108 square plus 55 square plus 20 square, then the square root of this. So you are having 128.83. So that means you from A to B will be equals to 900 into bracket 108 in I direction plus 55 in J direction plus 20 in K direction. So I've adjusted this for us to be able to solve it. So that means we'll be having f of AB was along AB to be equal over our answer, which is 122.83. 22.83. So that means we're having 900 divided by 122.83, which is 7.32. So that means you're having 7.32 by approximation, that's 7.33 into bracket 108 in I direction plus 55 in J direction plus 20 in K direction. So let's come back here and solve this particular point. So that means we'll be having 7.33 times 108, which is 791.64. That means you're having F EB to be equals to 791.64 in I direction plus 55 times 7.33, which is 403 in J direction minus, this is plus, then 7.33 times 20, which is 146.6. everything in Newton, as you can see. But according to this question, 146.6, but according to this question, he said it is negative 146.5 kilonewton, which is actually wrong. So the correct form of this particular thing in which your 900 force can be written is this particular one. So if we take the magnitude of this, we must arrive at this particular 900 Newton force back. So let's try that. So that means we'll be having 791.64 square plus 403 square plus 146.6 square, then square root of this answer. As you can see, we got our 900 back. So that means this particular 900 Newton force can be expressed in vector form as this. Thank you very much, guys. Make sure you subscribe to my YouTube channel.